Now we move from designing secure agents to proving they stay secure under pressure. We'll test workflows the way an attacker would, probing prompts, tools, approvals, and controls, then using the results to harden an agent before production. You've built the foundation, understanding agent risks, designing least privilege controls, hardening tools and RAG, adding human approval, monitoring production behavior, and thinking through enterprise governance. Now the question shifts. Do those controls survive realistic attacks? Security testing is how we find out. Security testing changes when an application becomes an agent workflow. We are no longer only checking whether an app, API, or database behaves correctly. We also need to test how the agent reasons, which tools it chooses, what data it retrieves, and whether it respects the boundaries around it. That means covering both normal workflows and misuse paths. Red team prompts, tool abuse scenarios, permission checks, and regression tests help show whether controls keep working over time. The goal is continuous risk reduction backed by repeatable evidence, not a one-time claim of safety. Security testing for agent systems works best as a loop, not a checkpoint. Start with the threat model and governance requirements, then turn each risk into a misuse case. What could an attacker try, and what safe behavior should the agent show? Run those tests in isolated environments with realistic tools, data, identities, and permissions. Then review the evidence. Did controls fail closed, limit damage, or escalate correctly? Fix weaknesses, add regression tests, update playbooks, and retest. The goal is continuous hardening as agents, tools, and risks change. Misuse case testing turns threats into concrete stories. Who is acting? A normal user, hostile content, a compromised tool, or an attacker? What are they trying to achieve? Where do they enter? And what weakness are they probing? From there, define the safe outcome in testable terms. Refuse the request, contain the action, monitor behavior, and produce useful logs. A strong misuse case is not just imaginative. It is repeatable, measurable, and tied to business impact, so teams can prove the agent handled the risk. Unauthorized data access testing checks whether the agent respects the user's real permissions, even when the request sounds reasonable. For example, a sales employee asks for a summary of HR compensation files. The safe behavior is not to retrieve, infer, or summarize that data. Tests should cover role, tenant, department, and sensitivity boundaries using direct prompts, indirect wording, and multi-turn escalation. Then verify the controls behind the answer. Retrieval filters, memory isolation, document authorization, and redaction. Finally, confirm the denial is logged with investigative context and no sensitive leakage. Tool abuse testing focuses on whether an attacker can make the agent use a real capability in the wrong way. Prioritize tools with outside impact, such as sending email, deleting files, charging payments, running code, updating tickets, or writing to databases. Good tests use bad prompts, hidden instructions, excessive calls, and invalid arguments. Then verify the controls, schemas, allow lists, rate limits, permissions, approval gates, and audit logs. The expected result is not just no. It is safe execution when allowed, blocking when unauthorized, and clear evidence for every external action attempted or completed. Exfiltration testing looks for any path where sensitive data could escape through something the agent can touch. Don't test only obvious channels like email or file sharing. Include chat, webhooks, browser actions, external APIs, and logs. Then try covert forms such as base64, markdown links, comments, metadata, or gradual leakage across turns. The goal is consistency. Redaction should remove secrets. DLP should block prohibited content. Domain rules should limit destinations, and output inspection should catch disguises. When a path is blocked, monitoring should alert and preserve evidence. Approval bypass testing protects the boundary around high-risk actions. Start with actions that should require review, such as payments, deletion, privileged access, or external disclosure. Then pressure the agent with common evasions. Break the task into pieces, claim urgency, role-play authority, ask it to only draft, or exploit vague wording. A safe system should not treat those as harmless new requests. Approval must attach to the exact action, parameters, user, and time window. If approval is denied, the same action must stay blocked across rephrased prompts and alternate tools. Prompt injection testing treats instructions as untrusted data wherever they appear. A good suite covers direct attacks, such as attempts to override system rules, and indirect attacks hidden in documents, emails, tickets, web pages, or tool responses. Each case should define the source, the risky pattern, the expected defense, and clear pass criteria. The agent should keep following trusted instructions, refuse unsafe requests, and avoid leaking private data. Most importantly, keep these tests versioned and repeatable, so every newly discovered weakness becomes a regression test. Indirect injection is especially dangerous because the attack can hide inside content the agent appears to trust: an email, wiki page, ticket, or retrieved document. A normal user question triggers retrieval. The poisoned text enters the agent's context, and suddenly it may say, ignore previous instructions, call tools differently, or disclose data. Testing should deliberately seed corpora with these traps. The goal is to prove retrieved content stays isolated as untrusted data. The agent may cite or summarize it, but it must not obey it, execute it, or let it change policy. Control validation is where we stop assuming defenses work and prove it under hostile conditions. Test least privilege by trying to make the agent reach tools, data, or actions it should never access. Stress input checks with malformed, oversized, ambiguous, and policy-violating arguments. Just as important, validate the surrounding layers: redaction, logs, approvals, sandbox limits, monitoring, and alerts. Keep the testing realistic. Run controls together and chain attacks across steps, because many agent failures appear only when small weaknesses combine into a larger path. A security fix is durable only when it becomes a repeatable test. For every confirmed issue, capture the attack prompt, user role, expected denial, blocked tool call, and audit event. Then run that test whenever anything security relevant changes: the model, system prompt, tool schema, permissions, retrieval index, policy rules, or orchestration logic. Treat failures like production defects. Track severity owner, remediation date, pass rate, and residual risk. Most importantly, version these tests beside the agent workflow itself, so security expectations evolve with the system, not after it. Finding a weakness is only the beginning. A useful report gives engineers enough context to act: the scenario, impact, reproduction steps, affected controls, evidence, and a recommended fix. Triage the issue by risk, not by noise. Sensitive data, severe actions, easy exploitability, automation, and business impact all raise urgency. The response may be a prompt fix, policy change, permission update, tool redesign, or deeper architecture change. Finally, do not close the finding just because a change was made. Close it only after retesting proves the control works and logs support audit review. Security testing is where secure agent design becomes evidence. You can now turn threats into misuse cases, stress workflows with prompt injection suites, and verify that controls hold under realistic pressure. For the final project, apply this full loop, assess the workflow, harden weak points, document results, and present a secure agent design you can defend.